Welcome back to Behind the Glass. This week we're on the road once again. This time we're in the volunteer state of Tennessee, right at the foothills of the Great Smoky Mountains. In the small city of Sparta, Tennessee, you'll actually find the leading manufacturer for roto-molded fuel tanks, Dometic Fuel Systems. Today, we're going to be taking a close look at the build process from start to finish. With nearly 40 years experience building an industry-leading fuel tank, it's easy to see why Sportsman chose such a great supplier to work with. Dometic acquired Mher in 2017. Keeping their amazing team in charge, it was a smooth transition and a large growth opportunity for their manufacturing. With roughly 250,000 square feet of manufacturing space and close to 300 employees, Dometic is able to supply 80% of the marine industries with roto-molded tanks, making them the leading manufacturer of rotationally molded tanks. They've seen large growth as the marine industry has continued to grow, allowing them to push out 1,500 tanks a day, with just over 4 million tanks produced to date. Building this many tanks takes a highly skilled team of rotational molding technicians and great management, but it also takes some serious organization. Rotational molding or roto-molding is a manufacturing process to produce large volumes of hollow plastic parts. Roto-molding uses biaxial rotation and heat to produce these exceptionally strong parts that are stress-free, lightweight, durable, and have a seamless design. Roto-molding is commonly used due to its long list of advantages, the first being its cost-effective customizations. The cost of tooling or mold baking for rotational molds is very affordable in comparison to, say, an entire boat. That means that Dometic can quickly design and build new molds for each of our new models annually. When it comes to safety and compliance, roto-molding is a very popular option. Dometic tanks are built to exact EPA and CARB requirements with a seamless construction that minimizes potential leak points and ensures safety and environmental responsibility. One of the last but most important advantages is its performance and longevity. A roto-molded tank is extremely lightweight but still offers excellent load-bearing properties, making them a reliable choice for marine application. Rotational molding, as it sounds, needs a mold in order to fabricate the part. It's here where an invaluable team of engineers and designers must work to create tanks to fit perfectly into each boat design. When designing a new boat, the Sportsman team will closely work with the Dometic's team to meet all requirements and fit the tank in the most optimal spot for weight distribution, capacity, and maintenance. Once designs are solidified, it's a quick turnaround time for Dometic to begin production. Their mold fabrication team can take a design and build a new mold within a few days. Molds are made out of 1/4-inch aluminum. The aluminum is cut using a plasma cutter, and then the team of welders will weld and assemble all of the pieces to fabricate the mold that will remain in production for many years to come. We've discussed what roto-molding is and its advantages, but now let's take a look at exactly how it's done. The next steps follow a carefully timed sequence that yields the best part. Before the process starts, the molds will receive a water-based mold release agent that is applied roughly every 3 pulls. Once complete, the first step in the rotational molding process is to load the material that will soon become the structure of the part. Fuel tanks are built using 3 layers. The outer and inner layers are cross-linked polyethylene, which is a curable plastic powder. The middle layer is a proprietary EPA-certified hydrocarbon permeation barrier that bonds completely with the cross-linked layers. This reduces hydrocarbon emissions to protect the environment and meets the EPA and CARB regulations for fuel tanks. Each tank uses a predetermined amount of each of the powders, which is measured by weight. The cross-linked materials go through a thermoset chemical reaction at the target temperature of 360 degrees. Once this reaction has taken place, cross-link becomes an exceptionally resilient material. Once measured, the first layer will be loaded into the hollow aluminum mold that is mounted onto one of 4 arms on the rotational machine. Once all materials are loaded into the mold, they'll next enter the heating process. The plastic materials are then heated and rotated in 2 directions, which is why it is called biaxial machine, due to its biaxial rotation. The plastic will melt during the heating process and is spread across the mold and held in place by the rotation. This is known as layup or sintering. Temps in the oven will reach anywhere between 500 to 600 degrees. The part will move out, spinning will stop, and the second layer of materials can be loaded in. This process will repeat for the third and final layer. After about 40 minutes, all 3 layers will be cured and ready to enter the next phase. Once the plastic has been fully cooked and cured, it's removed from the oven, where it will then enter the cooling station. Each cooling station uses fans to cool the molds and the part, allowing the part to harden and form a hollow plastic tank. During the cooling process, the molds continue to spin to ensure that the part keeps its shape until fully solidified. On average, a fuel tank will take roughly 50 minutes to cool down and meet the target temperature of 140 degrees. If the part becomes any cooler, it begins to shrink, which can cause issues with removal from the mold. Once the part is fully cured, it's ready to be removed from the mold. Sportsman chooses to use an off-white colored tank as it helps to reduce heat absorption on hot summer days. Upon removal, each tank will be QC'd using high-powered lights to look for visible part defects that could include porosity or pinholes, thin areas, or foreign objects. Lastly, each part will be deflashed or trimmed of thin material left over from the edges of the mold. After this stage, the molds are ready to go back into production for another new part. The next step in the production process of roto-molded fuel tanks is assembly. This is where all the fixtures will be added to the tanks before final QC and shipment. Technicians will use a smart barcode system to pull up all of the needed information for each part, which includes drawings, tank assembly instructions, and any customer-specific requirements. The first step is similar to our cut and grind process, where all the holes are drilled out. This causes debris inside the tank. The following step will be cleaning using a vacuum and a microscopic camera to ensure that all the material and debris is removed from the interior of the tank. Next, the part kit is opened and technicians will begin installing all of the necessary components to our specifications. These parts include the diurnal venting system, fuel fills, pickups, and fuel senders. Once assembly has taken place, it's time for the tanks to move into the quality control, where they'll be inspected for any defects, leaks, or other problems that could have occurred. Every tank will be pressurized to 3.5 psi and then held underwater for 1 minute, ensuring that no leaks develop. This quality control testing meets and exceeds NMMA and ABYC standards. To ensure the best results after transportation, Sportsman technicians will actually pressurize the system one more time before installing the tank, but we'll take a look at that process a little bit later. Once all QC checks have been completed, it's time for each tank to move into the skid section. The skid area is where tanks will be loaded into pallets and secured for shipment. Due to the large size and lightweight of the tanks, it's important to stack and package tanks in a very economical manner to reduce shipping costs. For this team, it's a large game of Tetris. Tanks may sit in an area for a few days just to ensure that the skids are packed perfectly and saves customers on freight expenses, as well as fitting as many tanks as possible in a truck. Once packed up, the skids will move into the shipping department and be ready to load onto a truck and head to their destination. From here, all of these tanks will get delivered to their final destination. For us, we're going to continue the process back home with the installation of the fuel tanks. Welcome back to the Sportsman facility. So far, we've seen how Dometic builds the fuel tanks used in Sportsman boats. Now let's take a look at the steps taken to install each of the tanks in the boats. During the capping process of the build, this is where we will install the fuel tanks. The capping process is the installation of all below deck hardware and is finalized by bonding the hull and deck parts together. One piece of below deck hardware is the fuel tank. Once installed, the fuel tank is not designed to ever be removed again. This is why the following steps are so important to the process. Before installation, each fuel tank is pressure tested. The fuel tank is sealed off, a pressure gauge is attached, and air begins filling the tank. The tank must maintain 3 psi of pressure to pass the pressure test. Remember, each of these tanks pass multiple pressure tests before ever shipping to Sportsman, but we do our own test of checks to be certain that all parts are in perfect operating condition. Once pressure tests have been performed and the fuel tank is cleared of any potential leaks, it's time to install. The fuel tanks will be hooked up to a lift and raised up over the top of the hull. Technicians will lower the tank into the hull and begin fastening it down so that it fits perfectly in place. Once it's in place, the fuel fills and vent hoses will be connected and ran along the walls of the hull to where the fuel fills will be. Once the capping process begins, the fuel lines will be connected and secured to the fills that are installed on the deck. One last feature to note about pressurized fuel tanks is the fuel Ulage. Ulage is the air capacity inside of the fuel tank. Generally speaking, is roughly 7% to 10% of the tank. If your fuel tank is 100 gallons, you'll roughly have 10 gallons of fuel Ulage, meaning you will only be able to put 90 gallons into the tank. If you continue filling after the fuel pump clicks, you're at risk of expanding your fuel tank, which would cause a leak or total failure of your fuel tank. The pressurized tank is designed to prevent overfilling using fuel Ulage, and this prevents gases from leaking out into the air. This is an important safety feature when it comes to our NMMA and ABYC certifications, providing you and your family with the safest boating experience. Fuel tanks are not something that we think much about, but it's a very important part to a good day on the water. We'd like to thank the team at Dometic for bringing us into their facility and showing us their incredible processes. We hope you've enjoyed this episode of Behind the Glass and our visit to the Dometic facility. Don't forget to subscribe for the latest episodes and more content from Sportsman Boats. Thanks for watching.